All right, time for another draftphysics.com, debatephysics.com also. But the debate is just in this form of doing the detective work to figure out how the adversaries are murdering the truth. So, there's always a gimmick, a trick, some sort of bullshit that you have to go find and say, oh, okay, that's how you broke the experiment. That's all they're doing, is breaking the experiment to force the results to look the way they want them to look. And it's really so bad. And people are just called really bad. I mean, the very fact that we have to endure, video you can't even see anything. It's like filmed in fog with a shit camera. I mean, it's just so bad. But anyway, so Ian Gosling's video, the gimmick here is he obviously didn't put the same energy into the two experiments, so he's going to see if they oscillate at the same rate. And one of them, here's where one of them is, right? It's lined up here, and the other one's lined up here. Now, for a pendulum, theoretically, as it slows down, it still takes the same amount of time as when it has full energy. But as Professor Lewin will tell you, it only works for small angles. It breaks that rule if you put in too much energy. So obviously, he put in way too much. So for the half mass, he put in so much more. Gigantic difference. Huge difference. And there's no excuse for that except he knows what he's doing, and he knows it works better to his advantage if he cheats the experiment. Now, the other problem is he has these masses. It's a compound lever. Okay, so, you have to say, you're just saying, well, why is this gimmick? I mean, there's so many ways to be able to just dangle the weights, and then they're always applying the same pressure. They can't do anything else but just apply their weight. If you suspend them freely, they can only just weigh their weight, and wherever the stick is, they weigh their weight. But if you create I draw it, it just breaks the whole experiment. Now, the good news is it sort of verifies the theory I was talking about, how levers function. And it's really just about the center of mass. And it's not, I shouldn't say it's about the center of mass. Again, it's about I draw it, because there's just no way to explain it otherwise. All right, so just recognize why this? Why put in twice as much? I mean, it's almost like twice as much. It's like he lifted it up twice as high. There's no excuse for that. That can't be defended as some honest mistake. All right, so as I have previously explained, and I think it's pretty good to figure all this crap out over time, that levers behave differently depending on where you fulcrum them. So, depending on where you put the, how you suspend the lever itself, from the bottom or from the top, you get a completely different outcome in how the lever functions. And so, as I have pointed out, if you suspend it from the bottom, what happens is as the lever tilts, as it goes down this way, it's actually putting more mass on this side of the lever. So any flaw, any extra energy you put into the lever this way, it ends up just making the lever go all the way down. Okay, because you basically just put more mass on that side, and it's just going to stay down, even though you could take a little bit of the mass off and actually make it a little bit lighter. But the fact that it's tilted just guarantees the amount of mass of the lever itself that you've put onto that side has, made it so the lever can't recover, it can't balance. And the exact opposite happens when you suspend it from the top. When this side goes down, this side gets the extra mass and gets heavier. I don't know how to draw heavier, but it gets heavier. So as it going up, the further up it goes, the heavier this side gets. So that's what forces it back down to oscillate. All right. Now what he did is by suspending the masses rigidly, okay, you can sort of understand that the center of that mass is now farther away. Okay, the straight line, the mass is now going to be further away the higher up this goes. So the higher up this goes, the mass itself is moving further out, which means it's getting heavier. Okay, so it's the same principle. So by, on this other side's getting lighter. So you can sort of understand the center of mass is getting closer to the fulcrum when it's going down, and it's getting further from the fulcrum when it's going up. That's how he made a lever where he has the fulcrum in the middle. That's how he made it into a balance. That is a lever that oscillates, because it wouldn't oscillate if he had masses that just dangled, that were just suspended. Okay, because they're not going to change their center, and their application to the lever, the point that's feeling their pressure, is here, where here, obviously, this is a compound lever, so it's essentially just saying you made the lever longer. And the fact is when it goes up, it gets longer. When it goes down, it gets shorter. So obviously, you can make it oscillate a lot with a fulcrum in the center. So I didn't realize that's the gimmick. And so the problem with this is obviously the weight of this mass is constantly changing. So for every position the lever has, this is actually weighing a different amount because it's a different distance technically on the lever. So as it's going up, it's getting further and further out, which means it's getting heavier. And as it's going down, it's getting lighter and lighter. So that's another, I'd argue, just a flaw. If you're going to do the experiment, you really want the balance to always be balancing the same weights. You don't want to be you wouldn't want the weights to be moving on the lever, and essentially that's what having those extra fixed arms, dangling down. So I don't know what they call this. I think they call it a compound lever, but they use it in some other experiments where they actually create a balance and then put another balance on here, another balance over here. And the way they get away with that is because of the fact that they have it all rigid. All right. So just a gimmick. Just bullshit. All right. So now we'll do some disbar bullshit. All right. So I don't know how his camera's gotten worse and worse. So there seemed like he was doing all these pendulum videos where he seemed to be getting pretty good slow motion captures and all that kind of stuff, and now it's it's like Brozo quality or worse. Well, it's Gosling quality. It's just really bad. You can't see anything, can't read anything, just horrible. All right, so I'll grab a couple of clips. Well, maybe I'll just explain simple defects in his experiment. All right, so maybe I'll let that dry a little. All right, so let us continue. All right, so the idea is the lever launcher. Now, the way I did mine, okay, which is different than the way he did it. All right, I had a quick release that he now has, so he's conceded that the quick release works, that it does make a difference in how the experiment functions. All right, and so in my experiment, I was expanding a rubber band. Okay, so he's using a spring, which probably is a better idea, I think, depending on how much he's stressing the spring, I suppose. But what I did was set up the lever with tension when it's in a straight position. So the two objects would be suspended and be perfectly on their centers. Okay, so the pendulum's hanging straight up and into the blackboard, so to speak, and that would be their rest position, would be just making contact with the lever. So both of them are being launched from exactly the same location, and so you go from a nice what you would call perpendicular, okay, to the fulcrum position. So the lever's nice and perpendicular. nice and straight towards the direction, and it swings this way. All right, and launches the two objects from those identical positions. And so the difference he has done, okay, is that well, I guess I should draw it. Yeah, I should draw it in its distorted position. So he has his lever like this to start. All right, and he's going to put a stop here. I didn't bother with a stop because I said, what the hell's the difference? Just let him push the objects and let it use up whatever energy it's gotten, whatever contact it makes, and no problem. So he's got a stop here that goes to perpendicular. So he's stretching it this way. Now the problem with that is obviously one of these, okay, say if this was the pendulum, one of them is going to have a different angle to start with. It's going to be forward of the other one, or backward in this case, which was really dumb. But anyway, we'll get to the really dumb part. I mean, the big cheat part. We just could call it what it is. It's just the big cheat. So he did it, first he did a video even worse than the new one. Okay, no quick release. The weights were really dumb. So, I mean, the thing was he had a weight that was basically hollow. So it was a piece of metal, you know, I guess you call it a union for two threaded rods. And the thing is it's hollow. And so he could have, for the two mass, so instead of putting them side by side, he put them on top of each other, which obviously ruins the center of mass. It moves it up. So you can't do that. And what he could have just done is put a screw or a bolt inside of the piece to make it twice as heavy, and fill it with clay if he had to make it twice as heavy. So he could have thought of something better, so they would have the same profile. So in this case, in the second video, he has done a similar thing. He has some donut thing, and he's going to put a bolt on each side to make it twice as heavy, so it basically has the same aerodynamics anyway and the same center of mass. So those were improvements. And again, he conceded the quick release works. Now what you'll see, like I said, with this problem with the pendulum, you know, and the different angles, is this, when this was at a rest position, it wasn't actually touching the lever. So in the case of the lighter mass, the mass isn't touching the lever. So the lever is going to smack into it, hit it. So it's not going to push it, it's going to hit it, you know, and then push it. So it's a huge loss of the momentum. Anytime you hit something, we know that from collisions, that, you know, unless the lever weighs exactly how much, and unless it's made out of metal, it's made out of wood. So wood hitting the carbon fiber rod that he's using. So that's the other thing it did change. It has a small string and then a carbon rod, okay, and then the weight on that. And I don't think that's a bad idea, but who knows? So, but the point is the end piece is a nice little thing to be pushing on, but it actually has to be making contact with the lever, or else it's going to hit it instead of push it. And it's just a huge, we know collisions make a mess out of some things, especially collisions between objects that aren't hard steel. So you have carbon fiber hitting wood. Okay, not ideal. Not exactly what somebody thinks of when they think of elastic collision. All right, so I will put up the little clips where you can see the bullshit, and then we'll do some of the measuring crap too, and see how that goes. But so again, this is, you know, all you need is, you know, we're using numbers like 6 centimeters versus 5 centimeters, and you know, these numbers, just all you need to do, you know, 5 into 15 versus 7 into 15. You know, huge difference, right? 2 to 1 to 3 to 1. You know, 3 times. So it's, you know, it does make a big, getting these precisely correct is important. And obviously, you can't even read the scale, so there's no hope of doing anything precise, which you will see when I show you the video. Yeah, so that's good. Let's do that. All right, just since I have it here, this is the height of the 2 mass, and so you can't read anything on the scale. And I say this is a 9, so that's 10, 11, and so it's barely 12. He says it's 12 and a half. So, disputable. But anyway, but you can't read anything. It's just so bad. So anyway, we'll move on to the other image. All right, so this is an image of him he's gonna break the little quick release string, which isn't guaranteed to be in any particular position, which is a little less than ideal, but it's better than nothing. But anyway, you can see here. Okay, let me use the thingy. All right, you can see here. Here's the carbon rod, and so it has this lighter color going through. But he has these two little pieces of paper for whatever reason, like they're going to stop anything from moving. I doubt it. Anyway, and you can see that one piece of paper is actually over it, but you can't, the video quality is so bad you can't see that. But this one's obviously, you can see, is a little bit of an angle to it. So it's actually resting against the lever, and the piece of paper goes over the carbon fiber. So you can see that the rod goes straight all the way down and is against the stick. Okay, so we'll move on to the example of the one with one mass. Alright, so this is the one mass before it was launched, and it's pretty obvious. Whoops, yeah, I'm on the wrong thing. It's pretty obvious. Okay, you can see here's the rod going through. So the rod is outside. You can see it. So it can't be behind that piece of paper. So there's like a centimeter, well, 3/4 of a centimeter. And you can just see that it's not, so it can't be on the rod because it'd be covered by the paper if it was. There's no way you could still see it if it was against the rod. Now when I play the video, you'll see one frame, you can see it actually, the rod moves and nothing else is moving, so it clearly smacks into it, and you can see it's dangling straight down. So that's the problem with the way he did the experiment, is the one of them was arced and the other one's dangling straight down. So that's not ideal. Long way from it, actually. But anyway, this is just pretty glaring that it's outside the paper. You can see it right there. You can see it. And you shouldn't be able, it should be behind this piece of paper. This white box here is a little piece of paper. It should be behind that. So that's the bullshit. One of the bullshits. The biggest obvious bullshit. Anyway, okay, so we'll probably play the video. Alright, just for completeness, this is the one mass, and it's over, a little bit over the 21 line, but you can't see the 21, you can't see the numbers, so it's pretty bad. So you have to deduce them by counting up from the bottom where you do know a number, but really hard to see anything. Alright, so just, really, this should be deciding the truth, experiments of this quality. That's what you people think. I don't think you think. You must not be doing any thinking. Alright, back. So, I'll just go through some of the stills from the video. So he's using this weight. Let me do this. Well, I can use the mouse. As a stop, and that's a bad idea. So if you're going to use something to be this is how far I push it back each time, it should be a nail or something really permanent, because frankly in the other video you could see that it was pushed back further for the 2 mass than he did push it back for the 1 mass. So I'm not going to bother showing that since he's made a new improved video, but the old video was also flawed, and this is just not a consistent idea. So the idea is the quick release should just be a string or something. You put it over a nail, it's always the same size, so you make a bunch of loops that are the same size, around a tin can or something, and you just guarantee they're all the same size, and so then you're always pulling the spring back the same amount. Anyway, like I said, this isn't the ideal way to do the experiment because the 2 pendulums are starting from different positions, which they shouldn't be doing. Anyway, So next. So yeah, this view doesn't do you much good. Yeah. So he moves the ruler, if that's what you can call it, um, for the two different experiments because of the whole parallax problem and everything else. So I don't know whether it's good or bad. It's necessary, I suppose, but that's all you can say. So this is the top view. So he's hanging it from one position, but again, when he's doing the one mass, it's hanging down straight. When he's doing the two mass, it's canted. So that's not good. So here's the little paper things I was talking about. So you can see they have a real profile to them. And, you know, obviously, if the rod is touching the wood, you wouldn't be able to see it. So the fact that you could see it means it was out here. So it wasn't touching the lever. So the lever smacked into it, which is really bad for this type of experiment. So he's showing it here where it seems to be touching, but you can't see it that well, so you can't tell. So, but clearly in the images you could see that it wasn't touching. Yeah, so not much else. You can't see much there because of his finger. So right here you see it's behind the paper. So obviously you can't see it because it's behind the paper. And obviously you could see it in the other image, indicating it wasn't hitting the lever. And like I said, when I play the video, you'll see. See, it's covered here. You see, this is the one mass. It's going through, the carbon fiber's going through. You can't see it. It's completely blocked by the paper. And in the real video, when he's doing the experiment, it's sitting here where you can actually see it. And it's not hanging forward. See how forward this is? So, you know, what's that? How come this time now it's bent forward when it's hanging straight down in the real experiment? So clearly the real experiment and this image aren't totally coherent to each other for some reason. Yeah. So the weighing, it's always, Gosling said, well, I'm not going to put it in if you're not going to watch it. The point isn't for me to watch it. The point is for you to establish some sort of credibility. So it's always good to have it. I'm not going to play it in a video because it's boring. I don't need to play it. We have to believe you anyway. But the fact is, it's good to show your, hey, look, see, I'm not screwing around. I'm not making a mistake. So the carbon fiber weighs 3. Not irrelevant. Okay, I mean, if the one mass is going to weigh 40, so 3 is, 5% of 40, something like that. A little more. And so not insignificant. And so the rod in the two experiments is going to be moving different speeds. So in one experiment it's going 1V, and the second experiment is going 2V. So you've got twice the amount of energy stored in that carbon rod. So it goes from 5% to 10%. So it's not an insignificant amount of energy that the rod is stealing from the experiment. And he pretends it doesn't mean anything. It doesn't weigh anything. It weighs something.
Pendulum is only 3.15 grams. This is the one mass.
So you can see 40, so it's, 4 would be, 4 would be, 4 would, well, maybe my percentage is exaggerated. I have to think. 4 would be 10%, right? Can't be 10%. 10 times 4 is 40, so yeah, it has to be 10%. So 3 is obviously not an insignificant percentage of the mass.
40.35. Okay, this is the 2 mass. 83.75. So as you can see, so the 1 mass plus the pendulum is 43 grams.
Yeah, and somehow it's twice as, exactly twice as much with the other nuts. So somewhere there's a mistake.
Should be around 86.
A slight one.
And voila, it's perfect.
So it's not perfect because, as stated, that rod is going to be going twice the speed in one experiment versus the other. So it's obviously consumed, 5% times 2. Or something like that. So then he plays clips from my video for I don't know what reason. They're not the relevant clips. So anyway, so we get almost nothing in terms of the actual video. So there's just not going to be anything here. So that's all. Just like I said, I don't understand why he bothered playing the video. He's conceded now that quick releases are important. Well, they matter anyway. They make a difference. And so here's his quick release. So I guess what he did was pulled it back and then tied it, where I would make the strings exactly the same length so you can guarantee that you always have the same amount of compression in the spring. This is a little bit rickety, frankly. The lever does move a little this way and that way. It's a little wobbly. It's a piece of wood, so it bends a little. Not ideal, but okay. But like I said, when he doesn't have when this pendulum isn't actually on the stick before the experiment, that's a huge flaw. So we're only going to get a little tiny bit of video here at the end. Alright, so now we're getting close to videoing. Alright, so now we'll play it. So you can see that's the image I showed you, where you can see the carbon rod is sticking outside of the piece of paper. I mean, you can't see it because it's pretty small in this image, but I showed you that image. So I showed you this image, and clearly it's not against the stick, and it has to be hitting it. It has to be putting enough pressure on it to make good contact so there's no hitting involved. Alright, so we'll play this. And maybe I'll try to, let me try to blow it up. You can see that the pendulum's wobbling, so it's obviously not hitting this. It wouldn't be able to be doing any moving if it was actually in contact with the lever. So yeah, that's not bad. Maybe I could go a little bigger. Okay, it's a little better. You can see the carbon rods going straight through, and you can see it. So it's not touching the lever. Critical error, frankly. You can, see, it happens so fast. And he just does one trial, so that's all we get is the one trial. Alright, so let's go through it. So watch the initial motion. Come on, it should work, right? Not working. Working? Ah. Damn thing. Alright, maybe I have to do it this way. Yeah, there it goes. Alright, you should be able to see this. Alright, and watch the first motion. There. So this isn't moving. So the object itself isn't moving, but you can clearly see where the stick did move. So it hit it, and now it's going to move. But I mean, the frame rates are just awful in this video, so you can't do anything with frame rates. And there it goes. Alright. So I don't think I need to play that a second time, right? I think you saw pretty much everything you needed to see. Well, maybe we just do it once more for fun and to be something. Yeah, there it is. You can see it moving. It's going like this. So obviously if it was against the lever, it's not likely that it'd be wobbling or doing anything. So it's clearly not making contact. So it's going to get whacked. Instead of pushed, it's going to be smacked, which is really inefficient. Alright, I gotta do this thing. Now watch for the first motion. There. So you can see that the thing itself hasn't moved. And, you know, either the carbon fibers being bent or this is that, you know, you're just saying something's going on. But you can see the paper is now blurry. The lever's blurry. So obviously it's moving before the object is moving. And that's not desirable. So we'll play boom, 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 boom. Okay. So his numbers are 6.5 for the starting position and 7 for the other object. I'm not going to bother doing that. Close enough, maybe. I don't know. And 21. It's a little more than 21, frankly. And but whatever. So that's all he shows. So I'm just saying this is the video he plays. Doesn't have much in it. All right, let me fix the size again because you don't need it. Let's see. Yeah, what do I want to do? Oh, yeah, it's too big now. So let's make it smaller again. Yeah, much smaller. Jeez. All right. Yeah. Yeah. Well, that's good enough, I think. So that's all you get. All right. So this is the 2 mass at 1 distance. Now I'll point out again. You can see it right there. The paper doesn't cover this one at all, and you can just see it's right there, and you can see that it's slanted. So it's definitely being held by the lever. It's definitely putting pressure on it because it's not straight up and down. So this one's obviously making much better contact with the stick. Obviously. So that looks like a lot less energy to me, right? Okay, yeah, that looked pretty lame, frankly. Just going by the bounces even. You got to say, what? That's 0.4? They say the difference between those 2 experiments is 0.4. Yeah. Come on. 0.4 difference in the velocity? Yeah, bullshit. So anyway, so yeah, enough of that. And then, so it's, you know, he's saying it's 7 this time and 13 for the height. I'd say it's 12 plus, not 13. And again, it's a huge difference, right? You know, you just change these numbers a little bit and it starts to be a real difference. And again, the key feature to understand too is it's all dependent on, you know, the higher it goes, the less it goes this way, and the more it just goes that way, and only that way. And, you know, frankly, it's just a gigantic difference in terms of those 2 heights. But whatever. He clearly cheated the light mass. So he calculates it to be 2.4. I'd probably calculate it to be 2.7 or 3. So yeah, we disagree. And then the rest is just this stupid crap about the quick release. And he concedes the results are different when he uses the quick release. So he says, oh, yeah, we're still far from 4 times. Yeah, and we're still way over 1.4. So your results are still too much energy for the kinetic energy theory. And so you're saying, well, it's okay because, you know, creating some free extra energy is no big deal. Yeah, okay. Bullshit. So how did you do that? How did you screw up the experiment that you created that extra? Yeah. And obviously I would argue that you screwed it up because you shortchanged the lighter mass by smacking it instead of pushing it. All right, so is there anything else? I guess we could read comments, but that's just so unpleasant. But we'll see. All right, so comments, but there really isn't any. Yes, really. Let's see if I can find some more. So, you know, this 3, basically. Let's see what this actually says. This friend stuff. Don't let Goofy draw you in so much on quick release. So apparently they're all saying quick release doesn't matter. And I don't know why somebody would say that. They really think that these digits that we have are so precise. Yeah, it's just so silly. And why would they use it? I'm just saying, I've shown other Professor Lewin sitting there with a blowtorch burning the string. The other guy with the little match that burns down and then burns the string. Why did they bother doing that? Because they're idiots? Oh, it's a complete waste of time? No, it's because that's what precision requires. And they just couldn't care less. So they're against anything that implies doing it carefully and well. All right. I've lost one fingernail and dropped from my hand, which has given very consistent and accurate results. So what a pile of crap. I mean, his videos are absolute shit. He's got arrows that, point sideways. It's just the silliest shit. Let's see. Goofy only brings this up because he thinks somehow... No, I bring it up because I showed the experiment where I did the launching the little ball bearings down the rail, and there was a 30% difference. Huge difference. Okay, that so much energy is being lost in the launch, which then causes the half mass not to achieve twice the velocity. It's obviously more likely that you're going to fuck something up when it's going twice as fast. All right. When in reality, as you know, no matter how quick it is released, it can and will never happen. So again, they don't really understand that there's always drag in the release. So any slow release will create drag, friction. It would be idiotic to think it could be any other way. I mean, what an idiot. It seemed to recall you launched cars on a track with your hand and got consistent, so again, consistently wrong results. Okay, so it's just so stupid. Desperately trying to find energy that's not... No, you're the ones that just produced it. So his video came up twice now with, almost 2.5 instead of 2. So where did the 0.5 come from, asshole? I mean, it's whatever that is, right? 20% off. So why is the experiment 20% off? I'm going to argue it's 80% off, but whatever. It's because it's a junk experiment, and I just demonstrated how it's junk. I mean, you liars. You want me to actually put up the clips of the first experiment he did, and I'll show you the two overlapped levers, and you can see that one of them's pulled back further? I mean, you people are just so dishonest. All right. That's interesting to be reminded of. John pointed something out which sounds plausible explanation. What does that even mean to this comment? What does that even mean, Brozo? So Brozo did the experiment with a quick release. So this is the irony. When he did his lever experiment, he used a quick release. So, I mean, it's just hilarious. Yeah, I know, but I want to show him anyways that it doesn't make a huge difference. Depends on the experiment how much difference it's going to make and how much tension there is in the spring. And there's obviously in this experiment there's a lot of tension in the spring. I don't know why he's chosen to use so much pressure. You really wouldn't need that much pressure, so why is he using so much pressure? Because it's harder, who knows what stresses the system has. So again, is that their choice on purpose? The experiment comes out better if he puts more energy in because it wastes more? Isn't that what you're trying to achieve, is more waste? Yeah. It's still far from his prediction. So again, it's because it's still not done well. Let's see. I'm in the mood again to keep adjusting the experiment based on his remarks. I see how creative he will be to come up with more and more flaw. I mean, you could look at your own fucking video and you can see, oh yeah, I'm launching from two different positions. I have the same pendulum is in the same position. I got the launcher. I'm pushing them into two different positions. One of them isn't touching the lever. One of them is. You can't see that there's a little bit of a flaw in your fucking experiment, jackass? Oh, he's such an asshole. Also, he brought up his lever launcher on his porch again, claiming once again it looked like twice as fast. Yeah, it sure as hell did. So did your experiment. Looked like a hell of a lot more than point 0.4. That's for sure. Looked like a hell of a lot more than point 0.4. Amazing, right? Coming from a person who says time and time again experiments should be done clinically. And again, did I post my experiment as proof? No, I didn't title the video proof. I didn't say, here we're going, all right, prove it, prove it, prove it. Did I do any of that? No. It's a 2-year-old video. I just used it as a reference to say, well, it convinces me. Okay. But yeah, I don't have a high-speed camera. That's why I keep saying that somebody should do the experiments really well. They shouldn't be with nails and all this bullshit that we're doing. These experiments should be done well. And you won't say those fucking words. That's how fucking duplicitous these people are. They, of course, anyone who thinks science should be credible, who could be a pro-science person and say, no, we shouldn't do credible experiments. We should do fudgy, messy, sloppy experiments because it makes the science is so much better that way. That's what they're advocating. Okay. They don't want the proof. They don't want the Eddington experiment done from space. They don't want anything that has a risk of proving their crap wrong. So keep doing the experiments badly. That's what they want. They want Matchbox cars with the hot dogs glued to them. Okay, then it's a good evidence. Although Stephen and myself have analyzed his experiment on... Nope, it wasn't twice as fast, but 1.6 times faster at best. So that's just bullshit. But anyway, that's not 1.4, is it, jackass? 1.6 sure as fuck isn't 1.4, is it, fucker? Oh, god damn. So if we just take his 1.6 number, right? That's wait. So it's 40% off from my figure and 20% off of yours, something like that. You think that's that's good science? Fuck you. All right. The burn wire was a different position as the nail was. So again, if you look at his experiment, frankly, there's nothing stopping him from putting that tie in a little bit wrong angle. So and again, the stop that isn't a stop, it's a weight. You don't think you can push a weight out of position? So that's a little ridiculous, frankly. To have a stop that can be pushed out of position. Yeah, fuck that. That explains the difference, whatever. I thought he had gone a bit quiet on demanding quick release mechanisms. Why would you think that? You could also call it an independent release system. I mean, it just takes the human out of the equation. Why the fuck wouldn't a person who believes, who's an engineer, why wouldn't he think that would be the ideal, is to take the clumsy fingers out of the experiment? Oh, amazing bullshit. Oh, absolutely, Stephen. In fact, the case you haven't watched his videos for the past week's month, literally nothing has changed. So he says, oh, absolutely not, Stephen. Yes. However, your pool ball launcher remains the one and only decisive piece of evidence. So that's not what I said, but whatever. You really did a great job there, Stephen. So he says it's decisive when it's so damn close to proving. I mean, 19 and 11 is damn close to 20 and 10. However, every single other experiment you ever did is absolute garbage, but this one is gold. So he's being sarcastic. Oh, okay. Yeah, it's obviously you explain to me, Dispar, you little lying cunt. You explain to me how it was a flawed experiment. He sawed the sides off of a fucking pool ball, for fuck's sake. Pretty fucking smart. He did it on a glass surface. Pretty fucking smart. A lot smarter than you fucking dumb shit. Oh, damn. Regarding your idea about the lever museum, well, your lever launcher should be displayed. No, why don't you just redo it? It's not that complicated, okay? Just find some other mechanism besides rolling objects. Do it off the shelf kind of thing again. Launch something off the cliff, but instead of pushing a stupid bolt over a piece of wood, yeah, maybe do it on a piece of glass or something slick, a piece of steel. All right, let's see what he says here. Museum, as it's the only experiment in existence that comes close to 2-to-1 velocity ratio, even though you calculated 1.7 faster instead of 2 times faster. Yeah, damn close. As Gary said, I have all the lever experiments on my side. Yeah, the only ones that are... Show me the relevant one. I mean, should I use your lever experiment where the fucking goddamn thing isn't even hitting the lever? You're not even pushing it? Okay, meaning your lever experiment is one good setup, well performed, even though I did several... and every one of them was a piece of garbage. Yes, they're all absolute garbage. He puts a bolt, okay, with sides that are on an angle, and he's going to hit the angled side of the bolt. And you got to know that, well, that's probably not going to push it forward. It's probably going to push it up in the air. And of course, it's filmed in shit-o-vision, so who could know? But you can't see anything in the frames. Again, I'm the one saying this should be done with high-speed cameras. None of these people will write to, all these Paul Nord. They won't write to, what's the other guy, Bruce Yearney. Then the other guy I contacted, they won't write to any of those people and say, yeah, please do this experiment. You've got a high-speed camera, math and science guy. Yeah, why don't you do these experiments, okay, with your high-speed camera? They don't say that. All right, I have a duty to everyone to redo that experiment using the same pool balls, but this time ensuring no skidding will be possible. Yeah, we just put some oil on the glass and it's really going to be impossible. I mean, oily glass, I don't think it's going to be possible for you to roll anything unless you hit it with spin, unless you hit it crooked. Because that sped up the half pool ball. Yeah, well, bullshit, it did. Okay, and there could also, no, the angular rotation could only have hurt the heavier one. But the fact is it wasn't rotating at the same speed it would rotate on a gravel surface, so it wasn't much rotation. And there could also have been some skidding on the full ball too. Yeah, well, that's the question. We all don't know how much skidding is actually friction. It was a careless mistake for me not to consider this possibility, let alone observe it, or ensure it was observable with marks on the ball. Well, I mean, the ball already has marks on it, and that's how I saw it, you moron. Oh, sorry, you idiot. Oh, look, a whole bunch of brozosiums. So I was the one who noticed the angular rotation, by the way. Okay, and my second repeat of a similar experiment using copper rollers, that one was just absolute crap. So I can't even believe he's even going to bring that up because he cut the center out. So he's got more mass on the outside, which is a fatal flaw. I mean, that's just a gigantic flaw. There's demos, of all kinds of physicists doing demos with a hollow ring and a solid ring, and how they roll completely different down a ramp because one of them's going to store a hell of a lot more motion in its angular rotation. So that experiment was just absolute crap. Copper rollers caused a different controversy when I doubled the mass by filling one with lead. Yes, you can't have all the mass on the outside in one experiment, then all the mass almost in the inside in the other experiment. Yeah, that won't work, dumbass. So it's best to repeat using exact same balls and lever. I've spent hours looking for a half pool ball, which I found only a few weeks ago. A half pool ball. I don't even know what that means. Clearly you could drill holes in one, and then just fill the outside. Put a little epoxy on the outside. So you could hollow it out with a drill and then just epoxy the outside. But packed away along with everything else in my house in anticipation of rewire. So we're still doing this rewiring thing? That was like 10 years ago. It's proving quite invasive, elusive. I could make it again, but it was so troublesome the first time because very hard material to saw through accurately and sand down to perfection. Well, like I said, just use a drill. I mean, you could just drill it out, right? I mean, you could. Anyway, I have plans to make sure it can't skid when superimpose video footage, for example, where it shows the skid and shows skidding makes it go faster, not slower, as Goofy claimed. Well, that's just absolute nonsense. I didn't say skidding makes it go slower, so that's just a lie. What I said is we don't know what percentage of skidding is still friction. Who knows? Do you know? I don't know. I mean, skidding isn't the same as hydroplaning. You know what I mean? So it's, you can have all kinds of skid. You can skid and leave rubber on the road, or you can skid over ice, So very different things. We all know he will still defer to the original, though, but at least it will give everyone proof to argue back at him. So he thinks doing the experiment better will be to his advantage, when no, it'll be to my advantage. Because if you actually also put a barrier to stop the ball from moving sideways, because you actually did see that, okay? The yellow ball did move at a funnier vector. So you wasted some of the energy because the ball moves sideways. So if you put a little stick on there to make sure the ball stays in position when you launch it, I think the yellow one will go even faster this time. Asshole. If he is right, then the results should be the same. No, they should be even better, you fucker. But I'm willing to bet the results will be different. So he puts this in capital letters. So you know what? It's kind of funny is he's conceding that the experiment was so close to 2-1, especially when you just looked at it. When you just watched the experiment, the yellow ball was going so much fucking faster. I mean, it just bang, And so he's almost conceding that the first experiment was completely in line with my prediction, because he's saying the results should be the same. No, ideally you should get 20 and 10, not 11 and 19. Yeah, so do it better, and it's just going to be better for me, asshole. But I'm willing to bet the results. I wish. You want to bet? What do you want to bet? You want to bet your shed? Everything in your shed, okay? You can have everything in my shed, and I get everything in your shed. But I'm willing to bet the results will be different, and he will have to come up with some garbage explanation why. So all my explanations aren't garbage, and that's just the absolute fact. So I just showed how liar Ian Gosling put like twice as much energy into the pendulum when he was doing his oscillating experiment. Twice the energy. All right. And then I just showed how Dispar didn't, but you could see the thing moving. So we know it wasn't hitting the lever. So we know he didn't push it. He smacked it. Big difference. So those are real facts. Right? It was a real fact that when fucking Dispar, the lying piece of garbage who left the crappy, shitty live video up, where he was knocking over the milk carton, and you had two things. One of them swinging an arc this big, and one of them swinging an arc this big, and then he puts a carton here. So when one of the objects is almost completely out of energy, it hits the carton, and the other one is barely lost 10% of its energy when it hits the carton. And he calls that a fair experiment. I mean, you people are such fucking liars. I mean, not to concede you've made gigantic mistakes in the past is just such bullshit. All right. And the fact is you don't take the garbage videos down. However, I never crossed my mind just how slippery the surface was, particularly with pool balls. Well, glass is pretty slippery, considering a pool ball. So I'm just saying, I mean, they have felt on a pool table because, and even that they skid on. I mean, you can skid a ball on a pool table fairly easily. Anyway, plus I was... I really do hope he redoes this experiment. Plus, I was woefully ignorant about the angular momentum aspect of rotating objects having a bearing on the speed. So again, the angular rotation was so minor, like one rotation for the whole distance. I mean, it was a tiny amount of angular rotation. And I was also woefully ignorant that a skidding object actually goes faster. So it doesn't go faster than anything. Obviously, if it's not losing any energy to rotation, it will go faster because it isn't losing any energy spinning something. But there really wasn't that much evidence. It was going twice as fast. It hit the surface twice as quickly. So obviously, if it was rotating, it didn't have enough time to do it. Okay, and then Michael Falwell pointed out examples of this. Well, whatever that is. Anyway, I was the one who brought the subject up. Anyway, my apologies to one and all for being the cause of all this, but I finally put this matter to rest. Of all this, but I will finally put this matter to rest as soon as possible. So that's great. We're going to get a new Brozo experiment. I'm sure he'll, actually, he'll actually find some shit in his house to smear on the lens of the camera, so we can't see anything. It's just his original video. Like I said, it's completely. It's such good evidence for my side, but it's filmed so bad and the video is so chopped into so many pieces that I can't even use it because it would take me hours to be able to extract anything of quality that I could superimpose or put the images on top of each other. I mean, it's such a piece of steaming shit. All right, anyway, my apologies to one. Okay, we did that. My apologies to Goofy, especially, seeing as I'm going to ruin his day. So listen to that. So that's the scientific attitude. Now, look, I mean, the fact is I've always had confidence about the outcome of these experiments. And, so to me, I guess I can understand that. But to defend the idea of free momentum and defend a theory that says it takes 25 times the fuel to spin something 5 times as fast. I know Brozo doesn't believe that's true. I mean, he's a Sparky, as he calls himself. He knows, okay, that twice the watts, twice the action, 3 times the watts, 3 times the action. There's no squared function. You can't change the voltage and get some squared function out of it, and that is directly proportional to force. You know that if you put twice the force in, you get twice the voltage or twice the amperage. You know you're going to increase one of those by doubling them and not quadratically increasing them. So he knows that he's not going to use 25 times the electricity if he cranks his drill up to 5 times as fast. He knows it's 5 times. Why is he defending such a rubbish shit moron theory? I mean, it's just so dumb. He can figure out that, well, yeah, an 8-pound bowling ball going 16 miles an hour really can't knock down more pins. I mean, for every pin it hits, yes, it's going to exchange its momentum. It can't exchange anything else. All it has is momentum. Can't make twice the momentum. So we know if it can't make twice the momentum, how the fuck can it do twice the work? It's just about hating me. So just to do his little petty wank, is all this is about. But it's hilarious that he thinks he's going to prove the law of the lever doesn't work, that, it really does take 25 times the fuel to move something 5 times faster, which is just so idiotic. I've explained the whole spring thing, right? Now, none of us, I didn't know it coming in. I don't think Brozo knew it coming in, that this fatal flaw springs have, where they collect energy really well. They can collect like 100% or 99%. But they release it shitty because they are moving when the object leaves. And the spring still has a whole bunch of energy it hasn't given the object because the spring is still moving. And so that accounts for the fact that you can't use a spring to push something twice as fast because the spring will be moving twice as fast when the thing leaves. So the spring has twice as much energy stuck in it. All right. He's such a nice bloke. I almost don't want to do it to him. Oh yeah, I'm so. Can I pay you to do it? Yeah, tell me. How shall I have to encourage you to get right to it? Oh, okay. But I'm not going to pay you if you're going to turn it into a shit clown video. So maybe I'll pay you not to do your typical clown video and just record the fucking experiment. Don't say anything. Don't do anything. Just record the fucking experiment. All right. Or I should let him continue to live in ignorance. Yeah, all right. It's just so fucking stupid. That I am some genius to be the only one who made an experiment he can admire. LOL. So you're clearly not the only one. But clearly, the point is you did a whole bunch of other experiments that were really dumb. The little stupid chess pieces bouncing up and down, where you obviously gave them jerky launch velocity rather than pulled them up and down. I mean, it was almost as bad as Falwell's idiotic experiment where his pulleys aren't really pulleys. And he moves the two objects with his hands and says, see, it works. Hilariously silly. All right, anyway. Well, he can admire it again soon. Good. Okay. I mean, he really thinks he's going to go from 19 to 11 to 1.4. He actually thinks it's going to be 10 and 1 and 14. He really thinks he's going to get it to move, get that lighter object to move that much slower. That it's only going 0.4 faster. No chance, moron. Okay, so at least that was worth the comment reading. A silly brozo statement. So anyway, we got another crappy experiment to look forward to. Let's just see if they can film it in something decent. Let's see if his little release mechanism will be as... I mean, ideally, the cutting string thing. I just cut the string, same difference. It really is a nice, efficient method. I mean, it just really does eliminate any possibility of your piece of plastic bending or, any fudging. I really shouldn't have to explain this to people, but, the launching thing, when you hit something, you give it a velocity and it bounces off the thing it's hitting. And so then the thing can move again and hit it again. And then it can move again and hit it again. So it doesn't just happen once. So when you don't have good contact between the thing you're pushing and you're going to end up hitting it, you're going to lose a lot of energy. All right, so I think that's enough of a video, but I'll go look around and see if there's anything else. Oh, no, I really think that's enough, right? Yeah, an hour. Yeah, it's more than enough. All right, anyway, until the next time and such and so forth and whatnot. I'm just so hungry to find some kind of real physics video somewhere. Just so bad. I do get sent some links, thank you, to the person who does that for years. So I really do appreciate it. They're often videos I've already seen, and there just isn't enough in them. There's no beef, so to speak. I just did see, one of those California videos they made back in, 1980. But yeah, it's so ambiguous, in its statements that you just can't nail it down and say, there, I gotcha. Because it's just too vague. Oh yes, energy is conserved. Well, what do you mean energy is conserved? Because again, every single time you transfer energy from different masses, you have to fuck up the kinetic energy. There's no choice. It can't possibly be conserved. Alright, anyway. So, till the next time, and such and so forth and whatnot.